Hey everyone, let's picture a situation. You just finished your DSA round and you were able to invert a binary tree like a boss. You were also able to find the shortest path in a graph. You were also able to find the next greater element using a stack, and you are feeling like the main character of the whole story. And then you walk into the low level design round. The interviewer maybe smiles and asks you to design a parking lot. And then suddenly your whole mind goes blank. You simply create a class, say for suppose a parking lot class, and then you create a class for car because car is what you are gonna park in the parking lot. And then you realize you forgot about the tickets, you forgot about the payments, you forgot about the person who's going to book the ticket for you, the operator who is going to allow you enter the parking lot. You forgot about the whole user journey of how the whole parking service will look like. And suddenly your code looks less like a design and more like a plate of Italian spaghetti. So, hi everyone. Currently, I am an SDE-2 at Amazon, and today I'm going to help you fix this. So, we are going to talk about low level design, which is a round that separates the junior developers from the senior engineers. So, by the end of this video, you will be able to understand, you will be able to get a roadmap of how to handle everything with respect to low level design rounds. What exactly is a low level design round? What are the expectations from SD2s at any product based company in these rounds? And how do you approach these rounds? So what are the different steps using which you can maybe excel at these rounds, right? So starting with, hey, everybody should have a question. What exactly is LLD? And a lot of people confuse it with system design, which is HLD, right? So I'll give a very simple situation which will help you understand the difference between LLD and HLD rounds. Okay, so think of building a house. Now, high level design is the architect's blueprint. It's about where does the kitchen go, where does the room go, where are the washrooms going to be present, where's going to be the balcony of the house, how does the plumbing connect to the city water. It's about scalability, it's about load balance, it's about databases, right? So in the context of a system, um, it's about the high level components of your backend system, right? So say for suppose you're building some service. Now you're not going to just have one single server who's going to be able to serve millions of requests coming from across the planet. So you might have bunch of servers who is going to help you receive request. Now before the server there sits a load balancer which will help you balance these load into across servers, isn't it? And there are going to be a lot of database machines which is going to help you store data, isn't it? There are going to be messaging queues which will help you do asynchronous communication. There are going to be CDN machines which is going to help you fetch multimedia files quicker. There are going to be so many bunch of backend components into a whole end-to-end system, like any notification system that you see, any messaging application that you see, any ride application that you see, any booking application that you see. There are so many backend components to it, isn't it? So this is what high level design looks like. This is what about system design is. It's about scalability, databases, load balancer, and all the other components that you see. So how do you build a scalable application? How do you build a scalable system that can help handle these many requests? Is all about doing a system design, is all about doing a high level design, right? Now what's LLD here? What's low level design? So that's the interior design and the wiring of the house. So it's about class diagrams, it's about schema design, it's about object oriented design, it's about writing code which is readable and extensible. So at the end of the day, all of these components that you have just seen, which one of them is, let's say, the server is where the core logic of your application lies, isn't it? This is where your core logic, this is where your business logic lies. So how are you going to code that business logic? How are you going to code your database? How are you going to write queries? How are you going to help connect to CDN layers? How are you going to write code for connecting to these asynchronous systems, right? So whenever you write code, whenever you write any type of code in your backend systems, there is where row level design falls into picture. So in an interview context, LLD usually comes in two flavors. Okay, the first one is object oriented design, which is also referred to as OOD, which is just about diagrams and logic, which is generally done using pen and paper. Okay, the second flavor is about machine coding, which is becoming very popular these days. And machine coding is about having to actually write a working code in 1.5 to 2 hours, and that should be passing all the test cases or all the functionalities or all the expectations from the interviewer's problem statement. And this is very common in all the startups like Flipkart, Uber, Swiggy, and sometimes even the big tech companies like Amazon, um, or Atlassian or Rippling. All these companies do also have machine coding rounds. Again, it depends upon the interviewer as well. And generally, these rounds are more popular in the startups. Okay. And object oriented design, they don't expect you to write the complete code, but they expect you to do the design. Now we will deep dive into what are the steps that you should be approaching in these design rounds. But in general, these are the two flavors, where in the object oriented design they will expect you to do the design part, which involves understanding the requirements, doing the class diagram, doing the schema design, doing the API design, and then connecting different classes interfaces together, defining the relationships. And machine coding is all about object oriented design plus implementation. So you need to even write code for whatever you have designed so far. So what are the expectations from an SDE-2? Because we are going to target SDE-2 roles, the bar is bit higher, right? An SDE-1 needs to make it work, but an SDE-2 needs to make it maintainable. And it's very important to understand, right? So here is what your interviewer or anybody like me is going to check off mentally while you code, right? These are some of the expectations that your interviewer, whomever you are going to um, approach your design or give your design, these are some of the things which your interviewer will expect from you. Okay, the very first thing that the interviewer will look for in your design is extensibility. What do you mean by extensibility? It's very simple as like, hey, let's say today you designed a system based upon the current set of requirements. Now, the requirements won't remain same for the next decade. The requirement keeps on evolving. Tomorrow you might have a new set of requirements that you would want to have in your product. So is your code modular enough? Is your code good enough to take care of those new requirements without having to redesign the whole code, without having to change a lot of existing code? That is all about extensibility. For example, in a parking lot system, if I ask you to add a new vehicle type, let's say a truck, does your whole code break? Right? If you have used lot of if else conditions, maybe you failed. Okay, so that is all about extensibility. Is your code capable enough to be extensible to new set of requirements that can come in future? The second thing that the interviewer will look for in your design is modularity. Now what is modularity? It's very simple as, is your whole code separated into logical classes? Right? Have you written every single thing in just one class? If yes, you have failed the interview. If you're asked to design a payment system, you cannot write the whole payment code in just one class, right? Is everything shoved into just one god class, one monster class? If yes, you are failing the interview. The third thing that the interviewer will look for is your design patterns. Again, this is very, very important. So are you really using patterns effectively to solve problems, or are you just inventing your own complex logic? Because why is this important? Let's understand this for a moment, right? Things have evolved for decades, right? um, People have built great systems over the last decades. People have built so much great systems in almost so many categories that you see around yourself. Almost every single thing that you're building today is some or what extension to already existing systems. Now, are we really using the learnings that people have had in the past, right? While designing systems, there are very, very common problems that people have already encountered, that you are also going to be very likely seeing those similar issues while designing systems. So, based upon all those learnings, some great folks have identified some design patterns. Design patterns are like more commonly occurring problems in software design. And based upon those design patterns, you can actually improve your design, because you know those patterns. And if you see a similar pattern while you design your system, let's implement that design pattern. Let's look for that design pattern in our solution. And if you do that, it is less likely that you encounter a similar problem in future. So those will help you use those learnings effectively to solve your problems, right? The fourth thing, which is again important to everyone, is concurrency. because we are not designing our systems for one person to be able to use. This is a modern world where there are so many people trying to access the system at the same time. And let me tell you, this is an SD2 killer, right? It's very important to understand, is your code that you are writing, is it thread safe, right? So maybe you can write it this way, that is your code thread safe, right? What happens if two users, let's say if you're designing a book my show like application, what happens if you two users try to book the same seat at the exact same microsecond? Is your system really able to handle it, right? You should not let, as a book my show owner, allow two persons to be able to book the same seat, right? Imagine an application like IRCTC, imagine a system like IRCTC. People, maybe thousands of people try to book the same seat or same set of seats within the same second, when the Tatkal bookings open. But till today, I've never heard of a situation where the same person gets the same seat, where two people get the same seat, because that is how those systems are built. So, is your code really capable enough to handle those situations? And these situations are also called as race conditions. So, your code should be full proof of race conditions, right? And then the last thing, which is also very important, is naming conventions. Naming conventions. This is also important. Okay, so please, for the love of code, don't name your variables like x, y, temporary, etc. We are not in a competitive coding contest anymore. Okay, this is a low level design. This is what your uh, teammates are going to also look at. So it's very important to write code in such a way that your teammates don't start hating you. Okay, and your teammates will start hating you if you're writing a spaghetti like code, which is more um, a solution for an Italian restaurant, right? And if you're not applying for a chef over there, then maybe you should start avoiding that. Okay, so let's look into the strategy now. How do you actually prepare for all of this? And you can't just memorize solutions, right? At the end of the day, there are so many systems. You can't just memorize solutions, which is some extent people are doing in DSA rounds. But in LLD rounds, you need a framework. You need to understand what are the important things that you should learn about, and based upon that, what is the different framework that using which you can approach the interviews. Okay, the step one, as per me, when you approach or when you prepare for LLD rounds, is the step one is master the solid principles. Master the solid principles. This is very very important. Okay, if you take nothing else from this video, just take this: learn solid principles. Solid principles stands for five different things, where S stands for single responsibility principle. Okay, this is not a teaching session, so I'm not going to teach you every single thing in this class or in this video. I'm just going to give you a quick overview. So S stands for single responsibility. It simply means, hey, one class or one unit of code should not do everything. It should just do one thing. Everybody should be assigned a designated responsibility. So a class should do one thing, or a method should do one thing. You should be able to define what a class does or what a method does. You cannot say, hey, this payment class does every single thing, right? That's what single responsibility is. That is what makes your code modular. And if you learn single responsibility principle, you will be able to get a green flag over modularity. Okay, the next one is open closed principle. O stands for open closed principle. It means your code should be open for extension and closed for modification. Okay, and that is what will give you a green flag for extensibility. So this principle says, hey, your code should be able to take up new requirements. But your code should not require a lot of modification. So it should be open for extensibility but closed for modifications. Okay, the third one is Liskov substitution principle. It's a it's a complex one as compared to the other ones, but Liskov substitution principle in general says that no children class should need any special handling. So it's more about relationship between parent and child classes. I would suggest all of you to give it a read once. Okay, the next one is interface segregation, which is more about how do you or how should you define interfaces in your whole system, and it should be as simple as possible. So interfaces should be as small as possible. The last one is dependency inversion principle, which is again, I would suggest all of you to read it because it's not possible to explain in one statement. And why I'm asking you to master the solid principle is because if you mention these during the interview while coding, you instantly get bonus points because now the interviewer knows that hey, you know about these basic terminologies, right? The next thing that you should learn about is step 2, which is design patterns. Now, what are design patterns? This is the utility belt. Okay, there are in general there are 23. I'm not sure about the exact number, but there are 23 design patterns, and these 23 design patterns is I think present in a book called Gang of Four. Okay, GOF, Gang of Four. But do not, I repeat, do not memorize all of them. You just need the Avengers of these design patterns. You just need to learn the core design patterns which are very common across different systems, right? For example, the first one could be, I'm just listing down importance of them. It doesn't mean that remaining are not important. It means these are more important. Okay. The first one which is very, very important is strategy design pattern. In general, design patterns are categorized into three different categories. The first one is structural. Second one is creational, and third one is behavioral. So structural design patterns are those design patterns which will help you deal with problems related to structuring of classes. Okay. Creational design patterns are design patterns which will help you deal with problems related to creation of objects. Behavioral design patterns are solutions to issues whenever you have to deal with behaviors or functionalities, right? So strategy design pattern falls into the category of behavioral. Again, I'm not going to go deep dive here, but strategy design pattern is important because it is great for payment methods. It's great for pricing logic. It's great when you have different ways of achieving the same thing. It's more about algorithmic pattern where you use a design pattern like strategy when you have multiple ways of achieving the same thing, and you can simply plug in an algorithm whenever you want to do so. The second one which is very important is factory. Factory is also sometimes referred to as abstract factory. There's a minute difference, but these design patterns are also important. Why is it important? Is because it is great for problems when you have problems with respect to creating objects, like hey, you need to create a car object or a bike object or a truck object, right? The third one is observer, which is again very important when you have um, problems with respect to notification systems, right? It's very important. The fourth one is singleton. Singleton is important for issues like, let's say, database connections or logging systems. The fifth one could be something like a builder pattern. Builder pattern is important whenever you have complex object creation issues, right? Again, I just repeat one more thing. Do not use a pattern just to show off because you know something. It's not necessarily that you are going to use it, because if you use a factory pattern to add two numbers, I will fail you. Okay. So understand that, hey, you should use it only if you're confident enough that it solves the problem. Okay. Then there's step 3. After you master solid principles, after you master design patterns, the step 3 is UML diagrams. Understand UML diagrams and understand schema design. Okay. What this means is you should practice drawing class diagrams. Okay. Arrows does matter, right? For example, using UML diagrams, UML is, by the way, standard for drawing different set of use case diagrams, class diagrams, object diagrams, etc. Right? It's a standard of, or it's a standard for visual language. Okay. So whenever you have so there are so many relationships whenever you deal with different entities. Relationships could be something like a has a relationship. Okay. Or relationships could be like a is a relationship. Is a stands for inheritance. Okay. Has a relationship stands for composition, or it's also called as association. Composition, association, aggregation, all of these are has a relationship. Again, there are types. I don't want to get deep dive here again. But what I'm trying to say is you need to brush up on these terminologies, on these UML constructs, which will help you draw the diagram in a better way. Okay. And then you need to also understand schema design. You need to brush up on your basic database schema design. Even in LLD, knowing how to store your data is going to help you structure your classes. I hope this makes sense. And then once you master these constructs, master these terminologies, master these concepts, the step 4 is to practice standard problems. Why is it important to practice standard problems? Is because here is where you practice the classics. They are going to teach you different set of things, right? For example, if you learn how to design parking lot, it is going to teach you inheritance. It is going to teach you pricing strategies. If you learn how to design snake and ladder, it is going to help you teach game loops. It is going to help you teach state management. If you learn how to design splitwise, it will teach you graph simplification. It will teach you something like expense management. If you learn how to teach movie ticket booking, it teaches you concurrency, it teaches you locking. So what I'm trying to say is whenever a problem statement is going to come in an interview, it doesn't mean that you need to design the whole system. It's not possible practically to design whole book my show like application within 1 hour or 45 minutes. It's practically impossible. So what is the purpose of these interviews is to look at what your thought process is. Are you really a team player? Are you really able to understand or clarify the requirements? Are you able to define the MVP requirements, the V0 requirements? And then are you able to give some solution to that, solving those set of requirements? That is what the purpose of these interviews are. So you need to understand what is the core feature of a given application. For example, if you are going to be asked to design a book my show like application, interviewer is not looking for the solution for a payment feature, right? Because payment is not the core feature of book my show. Payment is not the core feature of Swiggy. Payment is not the core feature of Zomato. The core feature of Swiggy and Zomato is food delivery. They are solving business problems for food delivery. Book my show is solving business problems for allowing you book tickets. So understand the business problem that a particular case study is solving, and you just need to stick to that MVP problem. MVP stands for minimal viable product. That means given a problem statement, are you able to identify the MVP? Are you able to identify the V0 requirements? Because if you identify V1 requirements, V2 requirements before V0, if you're looking at some um, great magical features or interesting features before even the basic features, you are failing in that interview. Say for suppose you're asked to design a messaging application. Now you are saying, hey, I should be allowed to send emojis or multimedia. But hey, my dear friends, the basic version of messaging application is to be able to send messages, right? So focus on those MVP requirements. Just you need to design that. You don't need to focus on so interesting shady features. Those are V1 future scope. You know, you're not designing for that. If you're doing that, you are failing yourself. You're pushing towards yourself towards a failure. Okay. Now the next section of the video is about steps, or it could also be a framework for LLD rounds. It looks very simple. The first is identify the core requirements. Identify the core requirements. And this is what I have been speaking for the last 5 minutes. So you don't need to start coding immediately. You need to ask questions, right? The questions could be like, hey, in the case of parking lot, is this going to be a multi-story parking lot? Do we need to support different currencies, right? Are we building a CLI application or are we building a web application? Please understand, a silent interview is a failed interview, right? You need to ask the right question. That is where the interviewer understand that you're curious enough to understand the requirements and then approach the discussions, because it's very important for you to be able to identify as a team player. Okay. And then while doing so, you should also be able to handle edge cases. Handle edge cases. Okay. What if the input is null? What if the payment fails? As an SD2, you are expected to handle the sad path, right? Not just the happy path. You need to understand these edge cases, visualize them, identify them, and tackle for them in your design. You need to understand the nuances of every single thing. Okay. Then once you do this, then you are good to start with your class diagram. Class diagram is the core, is the meat of your interview. Okay. And then you can do your API design. If you understand the REST guidelines, you can do the API design. You can also approach the schema design depending upon the expectations, and you can also clarify this with your interviewer. Okay. You can also give some basic code structure of how is your API is going to interact with the system, etc., etc. Right. So these are more or less the overall idea of what LLD interviews looks like, what are the expectations, and how do you approach them, what is the framework. I'm also going to help you attach some of the resources in the video description which will help you prepare for this. Um, More or less these were the things that I wanted to talk about. So please understand that LLD is actually fun when you get a hang of it. So it's less about being a math wizard and it's more about being a logical architect, right? You need to focus on clean code, solid principles, and you don't need to panic while being in the interview. Okay. So this is what I wanted to talk about. I hope you learned something from the video. Again, thank you so much for listening to me for the last whatsoever minutes. Yeah, see you all in the next video. Thank you so much.